Welcome to today's lesson. We are going to look at centripetal force and centripetal acceleration. We start with the centripetal acceleration. We consider a body that is moving through a circular path. This body has a constant velocity in terms of magnitude, meaning that the magnitude of that velocity is not changing, but that particular body is said to accelerate. What makes this body to have acceleration is because the velocity is changing in direction at any instant. Remember, velocity is a vector quantity, so if it changes direction, then it is giving us a change in velocity. And when we have a change in velocity, then we have acceleration. From Newton's second law, when those bodies are moving in a circular path, they have a resultant force that is directed towards the center of circular path, and that force is what we call the centripetal force. But this acceleration again is directed towards the center of that circular path, and that acceleration is what we are calling centripetal acceleration. Then we look at the formula of getting centripetal acceleration. We have A is equals to V squared over R. If you remember our previous derivation, we have seen that V is equals to R omega. So if we put omega R here where we have V squared, we will simplify our equation to be A is equals to omega squared over R, because 1 over R will cancel. One of the R's here will cancel with this R that is in the denominator, and therefore our A becomes omega squared R. Then we look at centripetal force. This is the force that maintains the body in that circular path. It is directed towards the center of the circular path. If you have an object that is moving in a circular path and then suddenly you cut off that thread, that is, or that string that is tying that body, you'll find that that body will fly off and it will follow a straight line, a tangent, which implies that that particular body has what we are calling the linear velocity. Then we look at factors affecting centripetal force. One, we have mass of the object M. This one you can do it practically. You can have two stones, one that is lighter and that one that is a bit heavier, and then you try to wheel them. You will realize that the one that is heavier will require more force to maintain in that circular path, but the one that is lighter will require less force, which implies that the heavier the object, the more the centripetal force. Therefore, we can simply say that mass of the object is directly proportional to the centripetal force. That is, if you increase the mass, the centripetal force needed also should be increased. Then the second factor is angular velocity of the object, omega. If you increase the rate of wheeling, you increase the rate, it implies that the centripetal force needed also increases. Then finally, we have radius of the path. If you reduce the radius of the path, then the centripetal force becomes larger, which implies the radius and the centripetal force are inversely proportional. If you increase one, the other one reduces. Then we can say that these factors can be tested or they can be proved using a turntable. In a turntable, we have that the increase in speed of a turntable increases the length of the spring. And if the length of the spring increases, then it means that the centripetal force is increased. When you use a shorter spring, there is more extension, which implies the shorter spring brings about a higher centripetal force. When you are using a heavy metal bar, more extension is produced, which implies again that the heavier the metal bar, the more the force that is required. We can get the results on the observations from turntable experiment, and this one is always explained using these graphs. We have a graph of force against omega squared, and this graph is a straight line through the origin, which implies that the force and the omega squared are directly proportional. Then we have a graph of v squared against r. It is again a straight line passing through the origin. Therefore, it implies that v squared is directly proportional to r. Then we have the conclusions. From those results, we can conclude that the force required to keep an object in a circular path increases with 1, an increase in the mass m of the body, an increase in the speed v of the object, a decrease in the radius r of the circular path. So mathematically, all these we can combine them in a formula where we say that our centripetal force F is directly proportional to mass, is directly proportional to v squared, and is inversely proportional to the radius of the circular path. So if we replace the sign of proportionality with an equal sign and a constant, and then we put that constant k to be equal to 1, then our equation becomes F is equals to mv squared over r. But from our previous derivation, we have seen that v is equals to r omega. So where we have v in this formula, we put r omega. And if you can see, our v is squared. So you're going to get r squared omega squared. But we have r in the denominator. Therefore, 1r will cancel out. So you're left with F is equals to mr omega squared. And our a, that is our acceleration, is v squared over r. So again, if we put v squared over r, we put a, or we replace with a, we will find that our F, which is our force, is equals to ma. And if this one, you remember the Newton's law of motion, this is the second Newton's law of motion. We can look at an example. We have a body having a mass of 0.8 kg. It is tied in a string and it is wheeled in a horizontal circle of radius 2m, that is 2 meters, with a speed of 2.16 meters per second. Calculate the centripetal acceleration, and number 2, the tension in the string. We have this as our calculations. We have centripetal acceleration. From what we have just derived, we have seen that our a is given by v squared over r. Our v is 2.16 and our r is 2 meters. So when we substitute those values into our equation, we have 2.16 times 2.16 divided by 2, you get 2.332 meters per second squared. That will give us the centripetal acceleration. We come to part B. We want to get the tension of the string, but we know that the tension is given by the centripetal force, and we have seen that the centripetal force, we can get it from mv squared over r, but the v squared over r is our a. Therefore, this is the same as saying Fc, that is our centripetal force, is equals to ma. Our m is 0.8 kg. Our a we have just calculated here as 2.332 meters per second. So multiplying the two using your calculators, you will get that your tension is 1.87 newtons. Then we have a quiz. Quiz yourself. At the end of each question, there is answer that is indicated there. But again, you will find that there are those questions that need to have statement, like for example, what type of force produces the centripetal force? This one, you're supposed to make sure that you're getting the answers from your head. For the calculations, calculate, practice until you get the answers at the end. Do more practice and ensure that you are able to get the correct answer. Thank you, and let us meet in the next lesson.